Hi everyone. Today we will discuss Newton's laws of motion. So before we start discussing Newton's laws of motion, let us see what is this real force. Now here if you consider the Newton's laws of motion, as you are aware of these forces, so there are three forces and we call them as first law, second law as well as the third law. Now here if you consider three in number give logic to the study of motion of body. So all these three laws just tell us how the movement will take place, whether it is the first law, second law or the third law. So it defines the study of motion of the bodies in general. Now if we consider this very closely, if we consider or if we analyze these laws very closely, we find strictly it cannot be treated as law as we call it as Newton's first law, second law, third law, but more than that it also defines the complete definition of the force. It gives us the complete definition of the force. From first law we get some concept of the force, from second law also we get some part of the force, and from the third law also we get the nature of the forces and all that. So combining these three laws we get the complete definition of the force. That force is termed as the real force. The forces which comes under the Newton's laws of motion, and that you can see throughout the mechanics and throughout the physics. The forces that we describe or that we discuss, that is defined as the real force. Now real force, because these forces always describe the motion of the bodies, as we have just said, motion of the bodies. And here in the definition of these forces from all the three laws, if you find in all the three laws forces are involved. First law gives some part of the definition of the force, second law gives you the magnitude of the forces, third law again gives us the nature of the forces and all that. So that you can see here. So first law, from the first law we get the functional definition of this. First law gives you the functional definition of the force. What will be the behavior of the force? Stating that the action of force is to change the velocity of a body. It means first law says because of the force only there can be change in the velocity, and change in the velocity is possible only when there is either acceleration or retardation. It means from that we get the concept that velocity can be changed only when a force will be applied. So that we get from the first law. So that we call the functional definition of the force. Second law gives you the quantitative and dimensional definition. This quantitative and dimensional definition means what will be the magnitude of that force. This gives us the basic concept that a force is needed to accelerate the body. Force is needed to change the velocity. That we get from the first law. Second law says how much magnitude, means what is the quantity of that force. So that is, so second law gives us the quantitative as well as the dimensional definition of the force. What will be the dimension of the force, with what are the physical quantities or physical parameters with which that force is involved and all that. And the third law, if you consider, the third law gives us the nature of the force. What will be the nature of those forces, and which we get it as a force of interaction. So from third law we get the nature of the force, and that is force of interaction. From the second law we get the magnitude of the forces, and that we say mass into this acceleration produced by the applied force, that is F is equal to m into a. So from there we get the magnitude of force as well as its dimensional definition. And from the first law we get the functional definition. That means without the force the velocity of the object cannot be changed. Neither it can be accelerated nor it can be retarded. Neither its velocity can increase nor its velocity can decrease without applying any force. So these are the concepts that we get from Newton's first law, second law as well as third law. So one by one we will discuss all these laws, the first, second as well as the third. Now here if you see the first law, so this law by Newton, it was written in Latin. It was written in Latin by Newton, and then it was described in all possible languages. Now this law states that every body continues in its state of rest And every body continues in a state of rest. Yani if it is at rest, it will remain at rest. So that is the state of rest. Means if it is at rest, and if its velocity is 0, its velocity will remain 0. It cannot be changed. Or in uniform motion, or it is moving with some uniform motion or some constant velocity. In a right line, either we say a right line, here that right line means the straight line, unless it is compelled to change that state by forces impressed upon it. Unless it is compelled to change that state by forces impressed upon it. That means if a body is at rest, it will remain at rest till a force is applied on it to change that state of rest. Similarly, if it is moving with some with the concept of this uniform motion, or if it is moving with some constant velocity, it will keep on moving with that constant velocity till this force is applied to change the state of motion. So either the object is at a state of rest, it is in a state of rest, or a state of motion. So it will maintain the state of rest, or it will maintain the state of motion till no external force is applied on this. So here if you consider, suppose you have this object of mass m. Now if this is at rest, it will remain at rest. It cannot change its position of its own. So some external force is needed. Some external force is needed to change the state. So if it is at rest, so if we apply some external force, suppose F, then only its state of rest will change and it will move to some state of motion. It will come to a state of motion. So till no external force is applied, if it is at rest, it will remain at rest. Similarly, if you say an object is moving, let us say this object is moving with some velocity v. If it is moving with some velocity v, it will keep on moving with the velocity v again till no external force is applied. So if no external force is applied, it will keep on moving with the velocity v. Now here you can have a confusion in your mind after listening to this statement, that when we throw a coin or when we roll a coin, after some time it comes to rest, or when we push some object, it starts moving but it comes to rest. Then why? From motion, state of motion, it comes to state of rest, and we have not applied any external force to bring it to rest. You or we, as an external agency, we feel that we have not applied any external force to bring it to rest, but some external force have already been applied, and that force is, if one of the force, if we talk of that, that will be your frictional force. So even if we are not applying any force, we as an external agency, we are not applying any external force to bring it to rest, it is the force of contact, yani contact force between this surface as well as this surface, which will be termed as your frictional force, which comes from the roughness of the surface. So here, because 100% smooth surface we can't expect, there will be little bit of friction everywhere. So because of that frictional force, because of the amount of that frictional force which starts acting on the object as soon as it starts moving, so that brings the object at rest. So there also there is some force which is starts acting on the object, and because of that it comes to rest. So from this we are clear that either the object will remain at rest if no external force is applied, that will be termed as your state of rest, or it will keep on moving, that will be termed as again state of motion till no external force is applied. So this concept we get from Newton's first law. Now when we say this object will maintain its state of rest or maintain a state of motion, so this means this object possesses some property in itself, because of which either it is able to maintain the state of rest position, or it is able to maintain its state of motion position till no external force is applied on it. That property, because of which it is able to maintain a state of rest or a state of motion, that is termed as inertia. So from the first law, we get the definition of inertia. This inertia is nothing but it is the resistance to change, and it tries to change its state of rest or states of motion. It means it doesn't allow Like suppose if it is at rest, when we apply force, then only it will change its state of rest. Similarly, when it is moving, if we apply some external force to oppose its motion, then only its velocity will start decreasing, or if we support the motion, it will start increasing. It means this object possesses the property because of which either it is in a tendency to maintain the state of rest or a state of motion, and that inertia, that property is termed as inertia. It is nothing but the resistive tendency of the object, or resistance to change. It has the resistance to change. It does not want to change. If it wants to be at a state of rest, it tries to maintain its state of rest. So it is its tendency, you can say, that I don't want to change the state of rest or state of motion. It wants to remain in the same, either in the static position or in the moving position. So that is called inertia, and that simply means resistance to change. It does not want to change, does not want to neither move, or nor if it is moving, neither wants to come back to the state of rest. So this property, again and again I am repeating, because this inertia, it's a very, very important concept. When we discuss the second law and the third law, from there we will get the concept of the inertial force. And that from the concept of the inertial force, again a new concept will come into picture, which will be termed as the pseudo force. So one by one we will discuss all these things. So inertia, it is the resistance to change. The system or the object wants to resist the change. If it is at rest, it does not want to change its state of rest. If it is moving, it does not want to change its state of motion. I hope this is clear. So here again, further if we analyze this, if an object is a state of rest or uniform motion in straight line, then its acceleration is 0. So if an object is in a state of rest or in uniform motion, if it is at rest, so it's obvious that acceleration is 0. If it is moving uniformly, so when it is moving uniformly, it means it is moving with some constant velocity. So when velocity is constant, it means there is no acceleration or there is no retardation. So it means either it is a state of rest or in uniform motion in a straight line, then its acceleration is 0. So I hope this is clear. So either you move with the uniform velocity, it means your velocity is constant, so there is no force acting on you, and when there is no force acting on you, it means there is no acceleration or there is no retardation. And obviously when you are at rest, your velocity is 0, that implies that acceleration or retardation is 0. So from here we get that the first law can be expressed in this way: if no forces are exerted, and again we can have a different interpretation of the first law, we can analyze in a different manner. The first law can also be expressed as if no forces are exerted on an object, no forces are exerted on an object, then the object's acceleration is 0. It means acceleration is possible only when force is applied, and if there is no force, it means there is no acceleration. So acceleration is outcome of the forces, whether it is acceleration or whether it is retardation, it is outcome of the force. Now when you are maintaining your uniform velocity or when you are maintaining your rest, it means in both the cases force is 0 or no forces are applied on it. We should not say force is 0, we should say no forces are acting. And when we say no forces are acting, it means either particularly there are no forces acting, or summation of all the forces, that is the resultant of all the forces, it is 0. Let us say you apply 5 Newton force from this side and 5 Newton from this side. So two forces are acting. It is not that the forces are not acting. Forces are acting, but still acceleration of this object will be 0, because this force and this force, they are cancelling out each other. This force is opposing this, so they are cancelling out each other. So even though forces are applied on the object, even though there are forces acting on the object, but still its acceleration is 0, because forces are cancelling each other, or summation of the forces or the resultant of the forces, it is 0. So in general, if we again redefine all these things, uniform velocity does not mean that the forces are not acting. Uniform velocity means the acceleration is zero, and acceleration is zero means either the forces are not acting, or summation of all the forces which are acting on that object or system, it is zero. Resultant of those forces, it is zero. In that case, in both the situation, either the forces are not acting, acceleration or retardation, it will be zero, or summation of all the forces which are acting on the object or the resultant of those forces acting on the object, it is zero. So in both the situation, we can say the velocity remains uniform. Or if it is at rest, again in the rest position, if you consider this object is at rest, so if it is at rest, still in that situation the forces can act. Forces are again acting from this side and this side of the same magnitude, but it opposite in direction. So obviously the resultant or summation of these forces, it will be zero. So it will maintain the state of rest. So state of rest or state of uniform motion does not imply that the forces are not acting. Forces can act, but in both the situation, summation of forces or the resultant of forces, it is zero, so that the particle or the object or the system will not be able to accelerate, or it will not be able to retard it. So here, this is what we have discussed. Now here you can see, more realistic approach is to use the vector property. Because force is a vector quantity, so when we use the vector property, and if you use the concept, this summation means the addition of all the, which kind of addition? It should be the vector addition, because force is a vector quantity, so it is the vector addition, because forces can act in all possible directions. It acts from this side, this way, it can act from this way. So in any of the directions the forces can act. Now so many forces are acting on this object, and the object is either at rest or it is maintaining its uniform velocity. That means sum of these forces or the resultant of all these forces is what? Zero. Now when we say resultant of these forces zero, or sum of these forces zero, when we use the word sum of these forces zero, it means the vector sum of all the forces, because force is a vector quantity, so vector sum of all the forces, it is zero. So if we consider this, now suppose these are the forces, different forces, F1, F2, F3, F4, all these forces are acting on an object. Now object is either at rest or it is moving with the uniform velocity. So summation of those forces or the resultant of those forces, it has to be zero. Now if you consider the vector sum or this, so we can write summation of all forces. It should be equal to, let us say, F1 plus F2 plus F3 and so on, and these are all vectors. So resultant of all these forces, addition of all these forces, sum of all these forces, it has to be zero. So this will be equal to zero if the object is maintaining its rest position or it is moving with the uniform velocity. So this is the significance of all that. And when summation of all the forces, if the resultant of all the forces, addition of all the vector addition of all the forces, if it is zero, it means the acceleration will be zero, because the particle or the object is either at rest or it is moving with the uniform velocity. In both the situation, acceleration is zero. So we have discussed the Newton's first law, and from this you have learned two concepts. One is the concept of inertia, and another is if a particle is maintaining its rest position or it is moving with uniform velocity, the resultant of all forces, sum of all the forces or addition of all the forces, and obviously force is a vector quantity, so vector addition of all the forces, it will be equal to zero. So summation of those forces, it is equal to zero, whether the particle is at rest or it is moving with uniform velocity. This implies that the acceleration of the particle is zero. So these are the two concepts that we get from Newton's first law. The inertial property, from where we get the definition of the inertial force, we get the definition of the pseudo forces. Later on we will be discussing all this concept, and the resultant of all forces acting on the system or the object, it is zero. So in the next class we will discuss Newton's second law and third law. Thank you.